to the graph. Okay, part A, inequality sign. We are not solving inequalities yet. We just learned the notation and what it means. Okay, for example, if I have x is less than 2, what it means graphically when x is less than 2, it means all the number less than 2, which means on the number line it will be to the left of that. Okay, now because it does not have equal sign, if it has equal sign it will look like this, but because it doesn't have equal sign, then we don't include the 2. In high school we use open circle. Now, but once we are in college algebra, then we will use instead of open circle, we use parentheses opening to the side where you will shade it. Okay, so this is what the graph look like if we have x less than 2, not including 2. If you don't include the endpoints, we use parentheses. Okay, now that's the graph. In interval notation, it will be from negative infinity up to 2, not including 2. Okay, so this is the left limit on the left. In this case, there is no limit on the left, so we use negative infinity, and the number on the right will be the limit on the right. Okay, now we usually say this is in wording, in words we say this is x is less than 2. Okay, for every number less than 2, so on and so forth. There are many ways to say this, but be aware that this is less than 2, not including 2. Okay, not including 2. Let's go on further. Then what happens, Thomas, if we include the endpoints? If we include the endpoints, then the inequality sign will have equal sign. Let's say x is greater equals to negative 3. Now you have equal sign there. So when it comes to graph in high school, we will graph that like we have negative 3, and because it includes the endpoints, we fill up the circle, right? And then we shade to the right because we want x to be greater or equal to that negative 3. Now that's what happened in high school. Okay, but now here we will use this notation. Now I don't want to say high school notation is wrong. No, that's not what I'm saying. What I'm saying that we update our notation right now. Instead of using closed circle, we use bracket. Okay, bracket means we include the endpoints, and the bracket will open to the region or to the side where you will shade it. Okay, so eventually, the further you go into college algebra, to be more precise, if you go to calculus, there is a chance that your textbook will only use this notation. Your textbook may only use this notation, and that's good enough. Okay, now for us right now, to emphasize that we shade to the right, we then do the shading. Okay, so I do not allow you to use this last notation yet, graphing yet. You need to use either one of these two, preferably the second one. Now, what happened to the interval notation? We start from negative 3 up to infinity. So on the left-hand side, the left-hand limit is negative 3. Because we include the endpoints, we use bracket. And the right-hand side goes to infinity. And we never include infinity. We cannot include infinity. Therefore, we use parentheses. Now, in wording, we usually say x is greater than or equal to. Greater than or equal to. -3. Another way to say it, x is at least -3. So the word at least means greater than or equal to. Okay, or if we want to say it in a negative way, x is not less than. -3, less than -3. Okay, those are for the wording. Now these two type of set, the one, the interval that includes infinity or negative infinity, is said to be unbounded interval because they include infinity or negative infinity, then they are called unbounded interval. Okay. Now, under what situation, Thomas, then it will be bounded? Well, if you have the limit on the left is a number, the limit on the right is a number. Let's say if we have x is between -4 and 5, including 5. Now then, pictorially, this is, you know what, let me just use here. Now, this is from -4, not including -4, so I use parentheses, right? Up to 5, including 5. Okay, and we shape the region or the segment that is in the interval. And in interval notation, we call this -4. We use parentheses because we don't include -4. Up to 5, we using bracket because we include the endpoint 5. Okay, because the left-hand limit and right-hand limit are numbers, none of them going to infinity, we say this is bounded interval. Okay, I hope so far it's easy enough. Now let's do some problem. I took picture of my textbook just to help you study a little bit. I will not do this all the time. I think I will just do this for the next 2 weeks. Okay, but the third week, I assume all of you have the textbook already. Okay, because this is not something, I believe the publisher will be okay for me to take pictures for a couple of pages, okay, to help you to study while you're waiting for your book. But this is not right to do all the time. Okay, please understand. Let's see, for example, from this problem set here, which problem you want to do? Let's choose some question. Okay, let's say we do maybe number 32. I saw a chat. Number 32, okay. And then how about number 36? And then number 42. Is it okay? Let me see if you have other idea. Number 38, fine. Let's do number 38 also. Okay. Number 32, let me do it on the right-hand side. I hope you can see it though. Number 32, we have x greater equals to -2. Get the verbal description. Part A, x is at least -2. Okay, or you can also say x is greater or equals to -2. We can also say all numbers greater or equal to or equal to -2. Now sketch the subset on the number line. So on the number line, we put -2 somewhere. Let's say this is our -2. Do I use parentheses or bracket? Because we have equal sign, we'll use bracket. Now do we open to the bracket opens to the right or to the left? Yeah, we want greater than, right? We want something greater than, means it is to the right of -2, okay, including the endpoint, so the bracket will open to the right. Okay, part C, is it bounded or unbounded? Well, it includes infinity. It goes all the way to the very far to the right, then it is unbounded. Okay, in interval notation, it is on the left hand limit, it's -2, including -2. On the right hand limit, that's infinity, and we never include infinity. That's why we use parentheses. Number 36. You know what? Let me jump to number. Yeah, let's do number 36 first. Number 36. Number 36, part A. If I sketch this, that will be everything to the left of 2, not including 2. So it would be to the left of 2, not including 2. Okay, not including 2. So x is less than 2. Okay, is it bounded or unbounded? It's unbounded because it includes infinity. Right? And the inequality, it will be x is less than -2 without equal sign. Without equal sign. Number 38. Okay. Part A, x is between 0 and 5 inclusive. That's one way to say it. Okay, inclusive means you include the endpoints. Or another way to say it, x is at least 0 and at most 5. So that's between 0 and 5. Okay, the number line, that's including 0, including 0, including 5. So it will be 0 here. Let's say I have 5 here, and I shade everything in between. Now, is it bounded or not? That's bounded because neither of them goes to infinity. Okay. In interval notation, is that interval notation we saw earlier? No. In the interval notation will be. So you see the graph and interval notation is very, very closely related. Okay, the left-hand limit is 0 using bracket. The right-hand limit is 5 using bracket. Okay. Then how about number 42? Number 42, the description. What's that? -1 to -1 with parentheses, 2 with bracket. So the interpretation, the verbal description will be all numbers, or x is all numbers greater than -1 but at most 2. line wise, the graph will be parenthesis -1, bracket 2, I shade in between. And because left and right hand limit are specific numbers, then they must be bounded. Okay. Now, how about number 44? Use inequality notation and interval notation to describe the set. How about number 44? Y is no more than 25. Y is no more than 25. Y is not more than. So it must be less than, equals to 25. Right? Not more than. It's no more than 25 means less than or equal to. Okay. Now in interval notation, let's sketch the graph first. It's at most 25, right? Okay, so the interval notation will be from -infinity up to 25 bracket. Okay. How about number 48? Number 48. K is less than 5, but no less than. No less than means greater or equals to -3. Okay, it's less than 5, but not less than -3. Okay, so number line wise, it will be from -3 on the left hand side up to 5, not including 5 on the right hand side. Interval notation, that will be -3 with bracket up to 5 with parentheses. Okay, now so far, any question? I hope you find it to be easy. Yeah, we will encounter this again, I think, in P6. We will see this again in is it P6? Let me take a look. No. Somewhere in chapter 1, when we deal with inequalities. Yeah. Okay, but this is so basic such that I think we can go over this with a textbook. Now, we'll go on further. How about absolute value? How about absolute value? Give me a second. I need to bring this back up. Second. Now, absolute value, I think we all know how to do already, but what I want to actually look more into the interpretation for absolute value. Absolute value notation. Now, absolute value notation is usually being used to depict or describe the distance between 2 points. So let's say this is 3 and this is 7. Then the distance between them, let's call that D for now. The distance between 3 and 7 is equals, we know that's 4, right? We know that's 4. But this is actually can be written as absolute of 7 minus 3 or absolute of 3 minus 7, either one. Because distance has to be positive, right? Now we know the distance is 4. Okay, so that's not a really big issue. What we want to emphasize right now is when we say definition, distance between A and B, we can denote it by D between A and B, is given by the absolute value of A minus B or the absolute value of B minus A. Okay, now how to compute absolute value, that's something we have learned before. Okay, yeah, that's something we have learned before. So for example, if we see what we have down here, somebody already said, oh, number 51 is 10. That's true. Okay, how about number 52? What is absolute zero? That's zero, right? Okay, basically we need to compute the guy inside the absolute value first. Okay, if there's any operation in the absolute inside the absolute value, we need to compute that first. So this is absolute 3, which is 3. Okay, now how about this guy, number 56? I will take care this absolute value first. What is absolute value of negative 3? That's 3, right? Okay. So that absolute of negative 3 is 3. So negative 3 minus 3 is negative 6. Okay. So I hope you see that we actually follow the order operations. Now it gets more complicated later on though. Here, I will compute the absolute of negative 3 first. So we will get negative 3 times 3, which is negative 9. So far, am I too fast? Okay, let's go further. Okay, let's go further. The following is actually harder because it's more conceptual, but you need this especially if you're going for calculus later on. Now, absolute of x is equal to x if the guy inside the absolute value is at least 0, while it is equal to negative x if x is negative. Well, the reason is because absolute of anything will be either positive or 0. So if the guy inside the house already positive, then you keep that positive, right? Now, but what happens if the guy inside the house is negative? How to make it positive? Then we slap that with another negative to make it positive. Does that make sense? Okay, now then what happened if we have question like number 60? Question like number 60. Absolute of x minus 1 over x minus 1 for x greater than 1. Now we need to first ask ourselves then x minus 1 is positive or negative? So if x greater than 1, what will x minus 1 be? Subtract by 1 both sides, x minus 1 is greater than 0, which is positive, right? Okay, now because x minus 1 is positive, then I can get rid of the absolute sign. Okay, and we also see x minus 1 is not 0, so I can simplify them. This is equal to 1. Now, in other words, if I change the question a little bit for x less than 0, for example, what happened to absolute of x minus 1 over x minus 1? Now, because x is less than 0, is negative, then what happened to x minus 1? It's not though. It's not becoming negative x minus 1. No. If x is less than 0, then x minus 1 is less than negative 1. Right? You subtract by 1 both sides. But if x is less than 1, less than -1, then it must be less than 0, right? It must be less than 0. Therefore, when I try to take this x minus 1, take the absolute value away from that x minus 1, I need to slap that with another negative sign to make it positive. Okay, x minus 1 is negative, but once it's coming out from absolute value, it's supposed to be positive. Now, how to make negative number becomes positive? You multiply by -1, okay? But this then, you see that they have common factor x minus 1 to cancel, so I get -1. Okay. Now let's go further, the easy ones here. Let's say we do number 62. Which one is greater? What is -4? Absolute of -4 is 4. Absolute of 4, also 4. So they are equal. How about number 64? What is negative of -6? Negative of absolute -6 is -6, right? Because absolute of -6 is 6, and I attach the negative outside. Compared to absolute of -6, that's also 6. So 6 is greater. -6 is less than 6. Okay. Furthermore, talking about distance. Find the distance between A and B. Let's do number 68, for example. The distance between A and B is equal to the absolute value of -126 minus -75. Okay, now the thing is, if we use this absolute value here, we don't need to think about which of these two numbers greater, which of these smaller. We just plug them in, A minus B. Okay, absolute of A minus B. This would be absolute of -126 plus 75. I think that's -51, huh? That's absolute of -51, which is 51. Okay. Now I do part of them here. Later on, your suggested homework will be the odd numbers. Let me write it down here. Suggested homework from P1 will be number 31 to number 49. 31 to 49. And then number 53 to 71. 53 to 71. When I say suggested homework, you don't need to turn it in. When I say suggested homework, you don't need to turn it in. You just need to work it out, and then if you have questions, feel free to ask me either by email or during my office hour. I prefer you to ask me question by email though. Don't wait until the office hour. Okay. Let's use office hour only if I cannot explain to you by email. Okay. That's for P1. That's your suggested homework. Let's go to P3. Now, what is P3? P3 is on polynomial. P3 is on polynomial. In this section, we will review how to add, subtract, multiply polynomials. Okay, now what is a polynomial? Polynomial, I keep it simple first. Polynomial, a term in a polynomial looks like looks like a x to the n, where the a is the coefficient, the n is the exponent, and the exponent has to be a positive integer. I think I should say non-negative integer to be more precise. Non-negative integer. Okay. This x here, we call that variable. Now, a polynomial is the sum of terms like that. Okay, let's say, for example, the following is a polynomial, 4x cubed minus 7x squared plus 5x plus 9. That's a polynomial. In fact, we say a polynomial is in standard form. It's in standard form if it is in descending order. Means the exponent starts from the highest exponent to the lowest exponent. Okay. Oh, by the way, the coefficient may be any number. It doesn't have to be integer. It may be decimal, maybe fraction. That's totally fine. It's the exponent has to be a non-negative integer. Okay. It's the exponent that has to be non-negative integer. Okay. Now, multivariable polynomial has more than one variable. So, for example, you may have 5x squared plus 4.2xy minus 3/4 y to the 7th. Now, that's also polynomial. We call that multivariable polynomial. Okay, we call that multivariable polynomial. Is it in standard form? No, because at least not for now, because it's multivariable. So there's basically pretty much no way for us to put them in descending order. Okay. So any terms with square root, for example, or cube root, okay, with radicals, or if the exponent is a fraction, it's not a polynomial. Okay. Now, but what we are interested in right now is more into the operation. So let's take a look on. Hold on, give me a second. Let's take a look on number 32. Is that a polynomial? Is that a polynomial? The answer is no. Why not? Yeah, one of the term has negative exponent. That's right. So the issue is here. Okay, so that's not a polynomial. How about number 34? Is that a polynomial? Now notice that I can rewrite this as 1/2 x squared plus x minus 3 half, right? So you see the exponent are all integer, right? So it is a polynomial. Number 36. Is that a polynomial? So notice that y to the fourth, square root of y, you will see that's actually y to the power of 1/2. Because that 1/2 exponent, then the exponent is not an integer, then it is not a polynomial. Okay. Now, next, the easy parts that I think I can just ask you to do right away. How about performing the operation and write it in standard form in descending order? Let's say number 38. Number 38, open the parentheses first though. Okay, basically you distribute by 1 here to get rid of that parenthesis and by -1 here to get rid of the parenthesis with that subtraction. So this will be 2x squared plus 1 minus x squared plus 2x minus 1. And then we combine like terms, which will then be, and we combine like terms, 2x squared minus x squared is just x squared, right? And then the x term, only one of them, so that's plus 2x, and the 1 cancels. Okay, now can you try for me number 40? Let me give you 1 minute. Number 40, I get negative 5x squared plus 1 plus 3x squared minus 5, right? Which will give us, the x squared term will give us negative 2x squared. And then the constant part is minus 4. Am I okay, by the way? Let me check. Okay, good. Now, what happened to number 44? Now, I would like you to do this, but here's the thing. We have a nested grouping symbol here. So what you're supposed to do, you will combine like, you basically need to simplify this first. Okay, now after you're done with that, then you distribute the negative, then combine like terms. Okay, so there will be at least 3 lines in your solutions. Okay, work it out. Let me do that too. Okay, so the first grouping, I just leave like that, minus bracket y squared plus 1 plus 3y minus 7. So if you think about it, I follow order operations. Okay, I follow order operations. So this will be equal to y cubed plus 1 minus y squared plus 3y minus 6. Then I open the parentheses with distributing the negative on the second group. So I get y cubed minus y squared minus 3y plus 7. Am I doing okay? Okay, good. Now, next, I think number 50 is quite easy, right? We basically do distribution. Okay, number 50, that will be, the first term is, so we distribute that negative 4x, right? So we will get negative 12x. plus 4x to the fourth. So I distribute this negative 4x to 3 and also to negative x cubed. Okay. Now, can you try number 54? Because they have fractions there, so you need to know how to deal with fraction. Okay, let me give you maybe 30 seconds for this. Oops, I forgot to record it earlier. Am I done with this? Yeah. And then for number 58, that's what we and number 60. Now work on number 62. Still working on that. Okay, but I will start working on this x to the fourth minus 2x cubed plus x squared plus x cubed minus 2x squared plus x minus 4x squared plus 8x plus 1. Then I purposely line them up according to the exponent, such that when I add them, it will be easier to do. This would be x to the fourth minus x cubed minus 5x squared plus 9x plus 1. Oh, no, you're right. Thank you. Thank you. Not plus 1. This is minus 4. Thank you. Good thing I checked my work. I actually cheat from one of you. I cheated from one of you. Yeah. I want to see if you did it right. It turns out I was the one doing wrong. Okay, now I think that's still easy, right? As long as you know the procedure, that kind of silly mistake will cost me half a point maybe, but the big long story, you FOIL, combine like terms is what you need to do. Now, the next couple questions here, basically doing the FOIL, but I want to focus on some special product. Okay, let me do it underneath, and later on we will go back up there. Some special product. Special product. You have seen this before. I just remind you again. The first one is difference of squares. Difference of squares product. So a plus b times a minus b. So the same terms but opposite sign in between. When you FOIL that, you will end up with a squared minus t squared. Okay. Now, of course, even though you can get the same result when you FOIL it, but they categorize that as a separate special product because they don't want you to waste your time that way. Okay, and the thing is, it also appears a lot in our problems though. Okay, second, perfect squares. Perfect square. That's if we have a plus b quantity square that is equal to a squared plus 2ab plus b squared. Okay, warning that this is not equal to a squared plus b squared. No, they are not. They are not. Okay, when you FOIL that, you will see that there are actually three terms. Now, in fact, to say even more, if this were a minus b quantity square, then it will have the same pattern except that this should be negative here. Okay. You may want to write this down. If you didn't write this down, please write it down. In fact, I would like you to write this in some kind of like a small flashcard that I would really like you to memorize. Okay, now you can see the problems from here. Number 68, for example. Number 68, 2x plus 3, 2x minus 3. Now, blah plus blah minus blah. So it will be the first term squared minus the second term squared. That's 4x squared minus 9. Thomas, hold on. Thomas, can I just go ahead with 4x squared minus 9 right away? Well, if you see that, go ahead. If you see that, go ahead. You know, but the thing is, eventually it gets a bit harder though. Yeah, eventually it gets a bit harder once it's more crowded, right? How about number 72? That's 5 minus 8x being squared. The first term is 25 coming from 5 squared minus 2 times blah times blah plus blah squared. Thomas, it's kind of hard for me to memorize that. Can I just FOIL it? Yeah, you can, but basically you will forever, with that kind of mentality, you will forever never learn anything new though, simply because it's hard. Yeah, simply because it's hard, then you never learn anything new. No, just do it. Okay, you're going to calculus, right? Some of you actually going to calculus for business. So there are things you have to memorize anyway, and you start from now. So you start from now memorizing some important stuff. Okay, this will be 25 minus 80x plus 64 squared. Now, how about number 78? Number 78, we have 8x plus 3 being squared. Let me give you 30 seconds. Okay, now the first term is 8x being squared plus 2 times 8x times 3 plus 3 squared. Again, if you think you feel comfortable in skipping that step, go ahead, okay? Yeah, go ahead. Now, I show this to you. I think I need to clarify something. I show this to you not because I cannot skip this step. No, not because I cannot skip this step. Okay, I can. But at the same time, I want to make my lecture to be something you can study at home, right? So if I write the final answer right away, you may wonder, how did Thomas teach, how did Thomas get that? So I want to make my writing to be something still speaking to you even during this weekend. Okay, and you want to write your notes also in that way though, such that a couple of days later, 1 week later, when you read your notes again, you still know what you do there. If you really want to skip little steps here and there, do it during your test. Just little steps, not a lot of steps. Okay, but for the purpose of studying, keep your notes something readable and understandable, especially for you. Yeah, what you don't want to happen is like, oh, this one is easy, and then 10 days later you read your own note, you don't know what you actually wrote at that time, right? That's silly. What's the point of taking notes if so? Okay, the purpose of writing, taking notes so that we can study from that. Okay, and other thing that I would like to mention, that's number 78. The big challenge is number 76 though. Oh, I like that one. Number 76. 3x plus 2y to the power of 3. How do we do this? We don't have formula for cube terms. So what should I do? We don't have formula for cube. Make it into squared first. So 3x plus 2y times 3x plus 2y being squared. Now then what you do is you use the perfect square for this, right? Then you will get 3 terms here. Okay. Now, and then with that 3 terms, you FOIL further. Okay. Then from there you FOIL further. Let me give you 2 minutes from here. Okay, when I FOIL that perfect square, I will get 9x squared plus 12xy plus y squared. I'm sorry, 4y squared. And then I FOIL that. Oh, my space is too small, but bear with me. That's 27x cubed plus 36x squared y plus 12xy squared plus 18x squared y plus 24xy squared plus 8y cubed. So when I combine like terms, I get 27x cubed plus 54x squared y plus 36xy squared plus 8y cubed. Let's see, did I do it right? Okay, it seems to be okay. Now, that's if we have cube. Okay, now if we take a look further on this question, do you think you can do number 80? You think you can do number 80? How will you do that? You'll FOIL it? Number 80. And yeah, that's actually a way to do it though. Let me write it down. X squared plus 3x minus 2. X squared minus 3x minus 2. You can FOIL that yourself, right? Do you need me to show you? Okay, so the first way is basically quote unquote FOIL it. Okay, that's the first way. The way we did the previous number 76, or the way we did number 62. Okay, but I want to show you more though. The second way has something to do with the pattern of these two polynomials. Notice that you can say this is the first term and this is the second term. Let me rewrite it. So I can see that as x squared minus 2 plus 3x times x squared minus 2 minus 3x. I can see it that way. And I treat this as one group. And I treat this as another group. You see, it suddenly becomes difference of squares. Do you notice that? So the second method, I can do x squared minus 2 being squared minus 3x being squared. Now, of course, this method only beneficial for you if you can do perfect square multiplication fast. Okay, this will be x to the 4th minus 4x squared plus 4 minus 9x squared. That will be x to the 4th minus 13x squared plus 4. Okay, the result you get should be the same to the first method you did. If you did the FOIL, then you should get the same. Okay, now The thing is, strangely, they actually mentioned this number 80 first, while the idea they did was actually the same, very similar idea to what they did in number 84. Okay, very similar idea. That's same idea. Now, then can you do number, let's say number 86? Can you try number 86? Number 86, x plus 1 minus y squared. Number 86, x plus 1 minus y squared. Consider the question. So you see this as the blah, and this is the blah. So blah minus blah square. You see that in that pattern. Okay, you see that in that pattern. So that will be blah squared minus 2 blah blah plus blah squared. I hope you see that pattern. And this will be x plus 1 squared times 2 negative times, minus 2 times 2 minus 2 times x plus 1 times y plus y squared. Now then for the yellow one, x plus 1 squared, you follow that further. Another special square, special product, right? X squared plus 2x plus 1 minus 2xy minus 2y plus y squared. Now notice that this number 86 can be written in a deceiving way. So if I write it this way, right, you may think, oh, you know what, I never have that pattern, right? Because I just learned x plus something being squared or x minus something being squared. I never see this. So let me just do it long way. Yeah, you can do it long way, but of course long way means, may mean longer time. Okay. What else? I think that's where I want to stop for this section. Your suggested homework will be from this section. Suggested homework will be P3, number 37 to number 99. Just do the odd ones. Okay. Now, to prepare you to what we will see on Tuesday, I would like you to watch factoring, watch chapter on factoring. Watch chapter on factoring. I need you to remind yourself on factoring. Now, but let me give you the skeleton. There are 5 types of factoring. There are 5 types of factoring. So when you study, you may want to study it in this order. Okay, the first one is greatest common factor. Greatest common factor. If you have common factor, always pull that common factor out first. Second, grouping. Usually greatest common factor and grouping method being combined in one section. The third one, trinomial with leading coefficient 1. With leading coefficient 1. So for example, if you need to factor x squared minus 6x minus 16, like that. Okay, the leading coefficient is 1. The grouping one, for example, if you have x cubed minus x squared minus 2x squared, and then minus 4x plus 8, in which you put them, the first two terms and the last two terms, like that, right? Okay, and the first one, greatest common factor example, suppose if you have 50x cubed minus 40x squared, then the common factor is 10x squared, right? Okay, and then level 4, trinomial with leading coefficient not 1. For example, when we have 2x squared minus 3x minus 2. Okay, and then the last type of factoring are special factors. The first one, difference of squares. That is a squared minus b squared equals to a plus b, a minus b, basically the backward of what we learned just now. Second, the perfect square. The perfect square case is when you have a pattern a squared plus or minus 2ab plus b squared. That will be a plus minus b squared. And the last one is the sum or difference of cubes. Where you see a cubed plus or minus b cubed equals to a plus b times a squared minus or plus ab plus b squared. Okay, now I think what you can do, you actually read, you read P4, okay, with all the examples. If you have the textbook, read P4. Okay, if you don't have the textbook, then you watch the lecture video from intermediate algebra. Okay, the lecture video I showed you last time on my website, right? Okay, I think that's for today. Any question?